All right, so a lot of people asked me to put this back up, so I know it's the same thing that we started with yesterday. But let's look at what we can figure out unit rate-wise. If we want to figure out the unit rate of what is one horse worth. Well, I have 3 horses equals 30. So what would each horse be worth? Derek? 10, right? And then I have pairs of horseshoes. So I've got a pair of horseshoes here and a pair of horseshoes here. So if this was 10, what would each pair of horseshoes be worth? Caleb? 4. So then I've got a pair of horseshoes and a pair of boots. And that equals 2. Here's what I mean by the devil is in the details. And I'm not going to say it. Hold on. Order, bring to front. I'm going to make this as big as possible. I'm not going to say what details most people are missing. Oh, okay. But when you look at the...
I've never seen that.
Okay.
If you see it, do not tell your peers. You will take away the fun. But if you're curious about this, this is now going to be the beginning of this lesson video. So if you want to see this again, go back and look at the 1-3 video. But the devil is in the details. The devil is in the details, which means that the details is what will screw you up. 1-3 is your homework. It is combined with 1-4. So I will make the due date reflect that. If we get to AO and you realize the due date is like unmanageable, let me know and I will change it. Because we'll do 1-4 on Monday, that due date should be Tuesday night. So Tuesday by midnight. But so yesterday we ended with our t-shirts and we found out that our deal for $2.99 for one shirt was our cheapest per shirt price. Make sure that those are the right ones. Sweet. Yeah.
Question. Aren't we supposed to do? Isn't
I think 1.2 is set to be due at the end of today, but I can extend it if you guys, if that's what you're requesting.
Well, no, I mean like when do we
I'm requesting that.
No, I mean like what's 1.2?
So look right here. 1.2 you should try to get it done by midnight tonight, but let's just do this. Most people haven't done it. So let's do Sunday night. Try to get this done by Sunday night. You've got all weekend now.
If we don't do it, you'll be dead.
All right, let's dive in because we got to cover a lot. Who can remind me of how I solve for a unit price? When we're talking about the price, we have a very specific process. Caleb, you've had your hand up for a while.
You do the price, divided by the other number.
Yeah, we always do price divided by the amount. So I would like if you would write here that when we do price divided by amount, that is how we solve for unit price. We solve for unit price by doing the price divided by whatever the amount is given. So it could be number of cookies, it could be weight ounces, it could be fluid ounces, it could be like t-shirts, it could be animals, whatever the amount is. Brady?
Can I say the answer?
Yeah, so I'm just going to run through these. So hold up. If you didn't get a chance to do these yesterday, take a moment. I'm going to drop these right here. You need one. Take a moment and try to compute all of these. Yeah, especially with the decimal work.
Okay.
Now, I encourage you when we're working with fractions, try to do as much in your head as possible because fractions are honestly kind of easier to work with. If you did not solve these yet, take a moment and compute these.
So I can't say the answer for everybody's done?
No.
Just give me a second. Why are you flashing? Anyone confused on this? Anyone need help? So, when we're trying to find the unit price, we want the price per one. So, back here on the front, if you're confused on finding the unit price, you can come back and say unit price, which I would highlight this if I was you, is always dollars on top, amount on bottom. So we do the division like that. So, back here, I have my dollars and my amount, so I'll take $3.96 and divide it by 2. Then I'll take $8.36 and divide it by 4. Does that make sense? That we're going to do the same thing for each of these, just the dollar amount divided by the ounces. What'd you say? So let me review it with everyone and see if it makes any sense. So make sure that you get written down what I have written down. So for my first one here, I'm going to take my 396 and divide it by my 2 because it's dollars divided by amount. And that comes out to give me a unit price. Acacia? $2.98. Now, let's go ahead and label this completely properly. That would be per.
I got 198.
Oh, yeah, check that. You might have typed in the 3 as something. I think you typed in as a 5 accidentally. Okay. 198. Fix that if you wrote it down incorrectly. My next one here, mistakes happen, would be the 836 divided by 4. Notice, it doesn't matter whether I write it horizontally or write it vertically. The division is still the division, regardless of how it's set up. Aiden, you got this? $2.09. Josh, my next one, I'm not going to show the work for it. Just go ahead and give me the answer.
Okay, I didn't get to that one. I was raising my hand for the other.
Awesome. Leah? $1.78 per ounce. And my final one down here, Ella? $1.81, you said?
Yeah.
So which of these is my best, cheapest unit price? Carolyn? The 8 ounces, which is tricky. Because us Americans, most people kind of have the idea in their head that if I buy a bigger quantity, I will save money because then it's cheaper per item. So, like, I challenge you, go to the grocery store, and I don't know if I talked about this in your class or not, but go look at toilet paper. Did we talk about toilet paper?
Yeah.
Okay, I forget what I said to what class. So, they do this with things like toilet paper. In your head, you're thinking, grab the big one, get the 80 rolls. We need lots of, but then you, like, if you compare the unit prices, the 32 roll might actually be cheaper per roll. And then I could just buy 2 of those or 3 of those, and I still get the cheapest unit price. So it would be cheaper to buy 2 8-ounce bottles than it would be to buy 1 16-ounce. That's kind of crazy. Katie?
Don't people do that so that you'll actually pay more?
Yeah. So if you don't think about the math, sorry, I had to think about what you were saying for a second. If you didn't think about the math and you bought the 16 fluid ounce one, you'd have paid more than you needed to. Yeah, so you could have saved money if you did the math. Making your life better with mathematics. Zion.
Basically, let's say you had a 4-pack of soda, right?
Yeah.
Little soda cans.
Mm-hmm.
They're gone.
And let's say it's $2.98 or whatever.
That's too expensive.
$2, whatever. And then you have a 6-pack for like $4 or $3 or whatever.
So you just talked about,
Wouldn't that be like the same, like?
so you said $2 for 4 cans, right? And then you said how much for 6?
3.
So if it was 3 for 6, 2 divided by 4 is 1/2 or 50 cents. 3 divided by 6 is 1/2 or 50 cents. Sometimes the various different quantities end up with the same unit price, but almost always they're different. So like I was at Kroger last night because by the time I got home from the football game, I was really hungry for wings, so I decided to go to Kroger. So they had Kroger, sit down, they had Kroger Cola, buy 3 for $1 a piece, get 1 free. So that'd be 4 for $3. Or the actual Coke or Pepsi or that stuff was $1 a piece if you buy 5. So difference in unit price there, but also difference in item. So when you're comparing unit prices, you have to make sure you're comparing the exact same item, just different quantities. So I can't compare Coke to Pepsi. I have to compare Coke to Coke, different sizes, right? If you guys go and explore this in the grocery store and come and have an interesting conversation with me, I might forgive or excuse some practice work, because the more you do outside of class applying this to the real world, the less I need to see you do our like fake practice if you actually practice it for real in the real world. So if you're curious about that, yeah, let me know. So when we look at these problems, and hang on to it for a second. When we look at these problems, I do not care that you actually structure it this rigidly, but some people, this helps your brain. When I look at a situation, I want to think about, what do I know right now? What do I need to figure out? And how can I do it? So, what do I know? What do I need? What's my plan of action? So, this problem is essentially done for you. Let's go through and highlight, underline the important stuff. A water pump moves 330 gallons of water in 22 minutes. When we're dealing with unit rates that involve time,
Rate, time.
I don't care what is on the top. The bottom will always be your time increments. So when we're solving rates that involve time, time is going to be my denominator. Now they want to know, how much water does this move in 39 minutes? So wait, they're not asking us for the unit rate. Josh, can you figure out?
You have to divide it first.
And
see
then
how much it is per every
Oh,
1
this was
minute.
on the homework.
I
And
know.
then multiply it by 39.
So the first thing we have to do is find our unit rate. Then we got to multiply it by 39 to actually find out how much it moved in 39. So first thing we do is find out the unit rate of gallons per minute. And since I want 1 minute, then I'll be able to multiply with it. So off to the side here, set up your gallons divided by your minutes. So we're going to have 330 gallons divided by 22 minutes.
Can we use a calculator for that?
Yes.
Because it seems more like when it's going to have a decimal. For some reason. It probably won't, because I'm always wrong.
It is 15.
Exactly.
And we can label that GPM for gallons per minute. Then if I take that 1 minute amount, and I actually want you guys to write out the work of why this works, so hang on to it for just a second. If I take my 15 gallons
Time.
per 1 minute and write it like a rate, or a ratio with the two comparisons, but remember, ratio has to be same units, rates are different units. I then want my answer to just be gallons. So I want to get rid of minutes, so I multiply by 39 minutes in the numerator. That will cancel the units. Minutes cancels with minutes. Don't write with the pen. Minutes cancels with minutes, and my answer will just leave me with the units of gallons. So all I need to do is 15 times 39, and I get my answer of, Carolyn?
585.
585. My label would just be gallons.
So it wouldn't say per.
No, because it's not a rate. My answer is how many gallons did we move. So I want you to try the example here
Is this
on
the
your own.
astronaut one?
If we know that an astronaut's diet, if you haven't seen it yet, you should watch the movie The Martian with your parents' permission, because there is some adult-esque language, but it's a great spacey movie if you're interested in space. If an astronaut's diet is supposed to contain 18 milligrams of iron for every 2 days, how much iron would he need for a 9-day trip?
So wait, what is it? 18?
If it contains 18 milligrams for every 2 days, how much would it need for a 9-day trip?
Oh, I think I know what to do.
This does not relate to this problem. This relates to this problem. So if you're going to write that word here, up here, we want to go ahead and look at this next problem. solve for 9 days, let's figure out the milligrams per day by setting up 18 divided by 2. Once we find the unit rate, we can then multiply that number. Yeah, there's your unit rate. Where's your unit rate? I see your unit rate. I know, but you should show that. Show your thinking, guys. And you can use those boxes. They walk around and see people avoiding writing in the boxes. Use it. What we know is 18 milligrams per 2 days. What does per tell me to do? Divide. So this turns into 18 divided by 2, and we get 9 milligrams per day. But that's 1 day. So then what do we need? We need, Zion.
We need. Well, I was gonna see if the answer that I got was right.
Well, slow down a minute then. So we need iron for 9 days. If this is 1 day, I take my unit rate and multiply. Sorry, I might as well label this. So this was the milligrams per day. And multiply that by 9 days, which will give me 81. So, and I know that this says plan, but I don't care that it says plan. What we end up with is 81 milligrams for, or you could say per, 9 days. All you have to do is take your unit rate and multiply by what the value was from the denominator. So days was our denominator, so then we can multiply by that and get rid of days.
I did another way where I just like I would say if 2 days you need to have 18.
So you did 2 days, 2 days, 2 days, and then
Yeah,
one more day.
plus
You
six.
still have to figure out that 1 day though,
Yeah.
right? So you had to figure out the unit rate at some point. Are we good enough that we can move on beyond the got it, move on to the 1-3 notes? I feel like, especially if you've tried the practice, this should be fairly good. So clip those in your binder. Oreos, that's not really breakfast.
I know, but she has that every day.
What?
She has that every day.
You need help with unit rates? What did you say? Oh, well, I know. So that is your breakfast. But it's not a very healthy one. Then again, neither are Pop-Tarts.
Is that why you're grumpy?
I don't like what Oreos do to my teeth. The chocolate stuff gets stuck in my teeth. Then if you don't check your teeth, you might like go talk to the girl that you like, and there's like black chocolate stuff stuck in my teeth. And my wife is like, "Ooh, you're gross."
It's like, do you brush your teeth?
Oh, thank you very much. Thank you. Why did I give so many extras? What am I doing? Apparently these are sticking together or something. All right. So,
5 minutes to get ready and get
when we talk about ratios,
Yay!
and I just said this literally a couple minutes ago, what's the difference between ratios and
I
rates?
think you said this yesterday.
I also said it yesterday, but I literally did just say it a couple minutes ago. Ellie?
Didn't you say
Ratios have to be comparing two items that deal with the same unit. What about rates?
Oh. It uses the word per and it's the amount per the time.
Yeah, it uses the word per. It's the amount per something, time or whatever we're dealing with, and the units don't match. So that's why our label uses the word per, because we always have two different units, like miles per minute or miles per gallon or whatever. So when we deal with ratios that involve fractions, let's say that we're making cookies. If you decide for the Phoenix Fair to make some cookies and you have a comparison of cups of flour to cups of milk, or tablespoons of sugar to tablespoons of something else. So let's say that we're dealing with fractional amounts. Because when you cook, a lot of times you have like half of a cup or a fourth of a cup or things like that where it's not a whole or an integer value of cups. So let's say here we have 4/5 divided by 6. So I want you guys to put an arrow. This is our main bar.
So the middle one's the main bar?
Yeah, so that's our main division or main fraction bar, the one between the 5 and the 6. So this is really 4/5 divided by 6. So what they do, and if you have a highlighter, I would suggest highlighting this so it makes sense. They look at the fraction involved because this is a complex fraction, a fraction inside of a fraction. They say, well, I can destroy my fraction that's inside of the fraction if I just multiply it by its denominator. Because this is essentially times 5/1, and the 5's cancel each other out, and the 4 just comes through. Now the 6 also multiplies by 5/1, and that becomes 30. So then we can simplify down to 2/15. But I personally do not think that's a very good method.
So you want to cross that out?
No, that does work. It is perfectly fine. I just don't think it's very good.
So
It takes too much drawing.
whenever we're dividing with fractions of 3, like with 3.
You would normally be told this situation, like in a story problem. You would not just be given the number setup.
But when we do, we would cross the, we would get rid of the number in the middle and times it.
Not necessarily always the number in the middle. So that's why I'm saying be careful. You're assuming the fraction in the fraction will be in the numerator. That's not always the case. So let's look at a few and then let me know if you still have a question.
Okay.
So I would actually, if I saw this problem over here, let's rewrite this 4/5 divided by 6, but do it horizontally. Because we can rewrite this as 4/5 divided by 6. And at this step,
So the bottom
What
one
would I-
you always push over to the side.
not necessarily, but like I just told Caleb, you would normally be given a problem like this in a story. So they would say you have 4/5 of a pizza to divide among 6 students.
Okay.
How much of the pizza does each student get?
Oh, okay.
So, like, when that would be like, let's say a pizza was cut into 10 slices, 4/5 is 8 slices. So, like, if I'm giving 4/5 of a pizza to 6 kids, how much will each of them get? It's not going to be an integer amount. It's going to be some kind of fraction amount. But if I set it up like this, Casey, do you know what I would do next? What would I do?
Add the 1 over 6 and keep changing.
Yeah, I turn my 6 into a fraction, and then I can keep change flip. Which is way easier because this becomes 4/5 times 1 over 6, which becomes that 4/30ths, which then would reduce to your 2/15ths. I personally always set up fraction division in the horizontal method.
That makes a lot more sense.
Yeah, that seems easier.
So, your other option, this is why in big bold letters I put another option. Your other option is to just, gotta zoom out.
Calculator.
When we have a ratio rate that involves fractions, we can multiply the numerator and denominator by the, what's it called when I flip a fraction? Oh, sorry. Yeah, reciprocal. I should be more specific when I'm looking for hands or just shout outs. And that process is your keep, change, flip. Yeah.
My math teacher used to say for reciprocal, it's reciprocal.
I said that too. So your math teacher still says that. Flip the recip. All right. So your neighbor commutes 12. Are we good? Your neighbor commutes 12 miles to get to work. You commute 9/10 of a mile to get to school. Nice for you. Write the ratio of your neighbor's commute to your commute as a fraction in simplest form. So let's look at what it's asking. Neighbor's commute to your commute. The order tells me what to do. So I set up my neighbor's commute.
What does commute mean?
Travel. So when you drive, you are commuting. When you walk, you're commuting. So the commutative property means I can move things. To commute honestly means to move.
I mean, I know commutative property. I just didn't know what commute meant.
Yeah, a commute is like a distance you have to travel.
Oh.
So like most people say like my drive to work, you could say my commute to work.
Oh.
Makes you sound fancier. So set up your neighbors. Always make it into a fraction if it's not yet. Then to your commute, that tells me the order of the ratio or the order of my division. We can then keep, change, flip. 12 over 1 times 10 over 9. Make sure we're writing this down. I see some hands that aren't doing anything. Becomes 120 over 9.
1 second.
Can we reduce? Is there anything I can divide them both by, Zion?
9.
I don't know if I can divide 120 by 9. I might be able to.
3.
3 for sure, right? So let's do 3 to start. If I divide by 3,
It'd be 40.
and guys, anytime I'm simplifying, I draw the arrows, and I don't know exactly when I got in this habit, but this is a good habit to get into so that you see I'm not doing any math really. I'm just simplifying the fraction. Like I'm not doing anything fancy. I'm just rewriting the fraction again. So if I divide by 3, I get 40 over 3. Now can 40 divide by 3?
Yeah.
No. Not nicely.
Not
So
nice.
this is your fraction in simplest form.
Oh.
Your neighbor commutes 40 compared to your commute 3.
That'd be funny if the
Oh, I
neighbor was a
Any
teacher
number
at your
can-
So now, hold up, because I see some like confused looks. If I wanted to talk about my commute being 1, I could reduce this down one more time. But this would become 13.3 over 1. So essentially, your neighbor's commute is 13.3 times your commute. So if your commute is 1, your neighbor's commute is now 13.3. But this is not fraction in simplest form, so we would stop right here. This essentially would be our unit comparison because I got it down to 1. Now it's not a unit rate because this is not a rate, but it's a unit comparison or unit ratio. Okay?
Are you still allowed to write that down?
What do you mean? Yeah, you can. It's just not the fraction in simplest form. So I would circle the 40 over 3 because that's where we would actually stop. Now, B, I want you to try on your own, but it flips the order around. B asks you to compare your commute to your neighbor's commute. So your distance is going to come first. Your neighbor's distance is going to come second. So try to set that up and then solve it.
Will it make a difference?
Yes, because when you turn around the order of the ratio, it completely changes how the ratio looks.
Okay.
So this will be yours compared to...
Oh, I get it now.
Any questions?
Oh, does it just literally flip?
Shh. That's part C. How do the ratios compare? How are they related? You're good. I like that you know it. That's just like, don't give it away. Don't be a spoiler.
Spoiler.
Yeah, spoiler alert. Don't give the answer away. Don't tell them who dies before they die.
Whoa.
Like in the movie, if you spoil a movie for somebody, you're like, oh yeah, that character dies. I'm like, what?
I thought we're supposed to read
I get
everything. What
So-
if Miss Goldring just tell us, Mister?
When I talk to you guys about like wait for your peers, that's I don't want you to give a spoiler. All right, so might as well use cards a little bit today. Oh, wine.
I haven't been picked yet.
And the cards?
I haven't picked one.
Your cards? I've seen your card as I shuffle through. All right, Aiden, how do I set this up? We're gonna rapid fire through these. So each person's only gonna answer one question. Aiden, how do I set this up?
9 over 10 divided by 12 over 1.
Yeah, 9/10 compared to or divided by your neighbor is 12 over 1. Piper, what do I do next?
Then
Because I have fraction divided by fraction, we would keep change flip, which becomes 9/10 times 1/12. Brandon is absent today. Josh, now I.
Oh, you put the equal sign.
Okay, I put the equal sign. Nice cop out there. Acacia, now I.
I know the answer.
But I don't care. I said you get 1.
I know. That's why I didn't.
multiply across.
Multiply straight across. Guys, some of you are still trying to make fraction multiplication hard. It's not. Just go straight through. Don't make it harder than it needs to be. Now, those of you that have been trying to do common denominator type stuff, that would still work if you do it properly, but you'll have a bunch of reducing that you have to do at the end. Hey, Josh, can you stop, please? Thank you very much. So, when I multiply straight through, my answer, Brady, comes out to be...
120 over 9.
Nope.
No. What? No,
That's
I
what
mean
you
9
got
over
on
120.
We're 9 over 120, which reduces to, go ahead and give me the...
13.
No, he got to do 2 steps.
Go ahead and give me the reduce.
Okay, it reduces to 3 over 40.
So, Reagan, when we talk about how these two parts are related... they are reciprocals. Because when you change the order of the ratio, you essentially just flip everything.
Write down reciprocal.
You must have 3 exclamation points on there.
Okay.
I just wrote there flip.
I'm joking. So, try the got it on your own. Be careful that it asks for the comparison of running to weightlifting. So running will come first, weightlifting will come second. They're both in hours, so they are both the same rate. If you have a question, please stick up a hand.
So wait, should we change these into?
No, they're both in hours. Now you could change them both into minutes, but that you don't need to.
Okay.
Yeah, because we're comparing the same units.
So, probably easy doing like so. Which one would we start? Which one would we start with?
Running.
Bro.
Josh, we're working independently. Even if you have this done, move on and keep working. Running to weightlifting. So running time will come first, then divided by weightlifting time will come second. Running comes first, then weightlifting comes second. That gets set up as a division.
Sweet.
Should we write the
Not
should
when
we
they're
write the
both on.
weightlifting time as a fraction?
What are you doing here? Why are you dividing by 60? But now dividing by 60 is going to turn them back into...
So I was putting them.
Yes.
Because if you're trying to just set them up as compared to each other, these should just be over 1. Remember, because if you want to not change a number, you just put it over 1. Yeah, so running time compared to weightlifting, keep change flip, boom, pound it. Yeah. All right.
Do we change the weightlifting time to a fraction?
You do not need, well, yes, you will. So, Carolyn, how do I start this?
3/4 divided by 2/1.
Because my running was 3/4 and my weightlifting was 2, I set up 3/4 divided by 2. Then, Ellie, what do I do next? Shh. Ooh, yeah. Before I can flip, I got to make it a fraction, though. So I agree. Hey, chill. I agree that we keep change flip, but I got to make it a fraction first. So now I get 3/4 times 1/2. And Sebastian, as my answer, I get
3/8.
3/8. So you spent 3/8 as much time running compared to your time lifting. So if you spent 3 minutes running, you spent 8 minutes lifting. If you spent 6 minutes running, you spent 16 minutes lifting. If you spent 9 minutes running, you spent 24 minutes lifting. So whatever we do, it's always that straight comparison. 3 compared to 8. Any questions on this? So now this key concept may be very confusing for some of you, and this is why we like the keep, change, flip process. But keep an open mind while I explain this for at least a minute, just like you did with Mr. Sherg this morning. You guys were awesome. Just don't talk for a minute. Keep your hands down. Don't think about questions. Just listen to what we're doing. When I have a fraction compared to a fraction, I could destroy this division by 4 if I multiply by 4 over 1. Does anybody not believe me on that? Because the 4 on top and bottom cancel each other. I could destroy this 7 if I multiplied by 7 over 1. Because the 7 on top and bottom would cancel. But I can't do two different things on top and bottom. So since I want to multiply by 4 on top, and I want to multiply by 7 on bottom, what's up? Yeah, you're fine. If I want to multiply by 4 on top, and I want to multiply by 7 on bottom, I need a number that does both. Why does 28 do both?
Because 4 times 7 equals 28.
Because 28 is times 4 and times 7. So I get my times 4, but I also get times 7. I get my times 7, but I also get times 4. Now this process is overly complicated because we could just keep, change, flip. So the other way is to just keep, change, flip. I only give this to you as another option. It's another tool in your toolbox. Now, if you understand tools, you'll understand this analogy, but that doesn't mean that the box wrench is better than the socket set, or that the socket set is better than the box wrench. They're just two different tools that can both be used for the same job.
Utility knife.
Can we ask a question?
Yes. Question. Casey.
Will there ever be a time when you will need these?
There will never be a time when you have to use that method, because you could always keep, change, flip if you wanted. Or I could, this would become a very long process, but I could multiply by 4 on top and 4 on bottom, get those answers, which would be 12, sorry, I should color code this. It would be 12 on top then, compared to the bottom would become 24/7. Because the top, the 4's canceled because this is like 4.
You can have a
Now hold up. Then we could multiply by 7, which is actually to get rid of the 7 on bottom, over 1 times 7. This would become 84 over 24. It's just a really messy process.
Yeah, I'm just gonna do
So
it.
yeah, it's not good. It's not.
My
Don't do it.
I won't.
Just don't.
Believe me, I'm already
don't.
broken.
It
My brain.
was.
Yeah, just stop.
So try A, B, and C using whichever method you want, but so that we've practiced it at least once. Because I know a lot of us will just go to keep, change, flip. Give me your eyes for a second. Here, if we wanted to destroy both denominators, 3 and 5, I want to destroy both of them at the same time. What could I multiply by that would get rid of the 5 and the 3? Olivia? 15. So that you have it practiced once, up here, times 15 over 1, down here, times 15 over 1. This numerator becomes 30 over 3. My denominator becomes 15 over 5. 30 over 3 equals 10. 15 over 5 equals 3. I can get to my answer and find out that this is true.
So we don't have to use that method.
No. For B and C, use whichever method you want. Try it on your own. So this is a complicated method. But going back to here, we want to get rid of both denominators at the same time. And actually, because I breezed over this kind of fast,
A little bit.
if you're going to try to use that method, which I actually don't suggest, which is why I breezed through it quickly, you want to go back and highlight on the front part that what it is the least common multiple of the denominators. So that's essentially what you're finding is you're looking at both denominators. And you're saying what's the least common multiple of them. So if I wanted to do that with the next problem, problem B from the back, my denominators are 5 and 7. So when I think about the least common multiple between them, that's 30. So I could multiply on top and bottom by 30 and get rid of both of them. Now I could do that, or I could see I have a fraction divided by a fraction and just set it up horizontally and then keep, change, flip. My preference is keep, change, flip. Because it's simpler and we understand it becomes multiplication because I use the reciprocal. So Leah, if I set this up as a horizontal division, 4/5 divided by 6/7, what's the next thing that I do? So I have division right now. Do I like fractions divided by fractions? No. So what do? Keep, change, flip. So this becomes 4/5 times 7/6. Do not forget to flip. That is where I see most mistakes happen. 7 times 4 then. 28 for my numerator. 5 times 6, 30 for my denominator. Can these reduce?
Yeah.
They're both even, so we always know that even values can reduce. 14/15. Which makes this
You just divided it by 2.
true. Trey. True. Brain getting ahead of
7.
itself.
It's try, bro. Keep writing Trey.
Anyone confident enough to walk me all the way through? Brady, since you said that your name is often not called, tell me what you did. Whole thing.
Well, I didn't do anything. I just wanted to be called on. You have to do 4/3 divided by 8/9.
And am I guessing that you wrote it out horizontally?
No, I didn't.
Well, that's why I said wrote it out. But what,
I
like,
wasn't looking up.
okay, so would, like, this is, in my opinion, the easier way. Otherwise, we have to identify a least common multiple between the two of them. And
What's 3 times 8?
that's what we can divide them both by. That's not a multiple.
Oh, it.
So think
Yeah.
multiples of 9 are 9, 18,
27.
27. It'd be 27. Well, no, 18 could work there actually.
Oh yeah, what?
Yeah.
20, in my opinion, 27 makes more sense, but 18 could work there. But I don't really like that method. You can use it if you want, and I can show that here in a second. But what would you do, Brady, since you said you wanted to walk all the way through?
Okay. And then, I would change it to, multiplication.
So you would do keep, change, flip?
Yeah.
Which becomes?
Okay, and that would be, totally have stuff written down. 36
Yeah.
over 24.
Yeah. Which can then reduce. I want to make your life easier. You don't have to do this, but you can if you choose. You can cross reduce when you see items diagonal from each other that can both be divided by the same thing. These I can divide each of them by 4 and get 1 and 2. These I can divide both of them by 3 and get 1 and 3, and that leads me to 3 over 2. Now you don't have to do that. You can multiply straight through and then reduce. But I essentially reduced before I multiplied. This is false.
I knew.
Because this is actually the reciprocal of the actual answer. So your homework is a combined assignment. The 1-3, if you start to struggle on it, don't worry about getting it done this weekend. Bring me questions on Monday. Okay? Have a great weekend. Sorry that you have weekend homework. I'll make that due like Tuesday night at earliest. Because we haven't covered 1-4 yet.
1-2 due on Sunday night.
1 Tuesday. But I'm not going to put the chapter 1 grades in math at least until like mid next week.
Wait, so when is 1-2 due?
Like Tuesday night.
Bunch of chairs.
Yeah, at earliest. But 1-3 is combined with 1-4, so it looks like one assignment. It is one assignment.
Are you gonna have like a sign up for AO? Because I need help on the very last.
Yeah, we all have one big combined AO, so I have people left over from yesterday I have to get to. So I don't know how many more people I'm going to be able to get to just because I have to work through yesterday's list first.